Welcome to our presentation. So our topic is wind energy by Talhat and Alima&Aidana. So here's the first appealed technology. It's a modern wind turbines efficiently generate electricity using advanced materials and control systems. Offshore and floating turbines expand energy potential. And then the next one, it's a history of wind energy. And from accident windmills to high-tech turbines, wind power has evolved. The 1970s oil crisis spurred innovation. It's making it a key renewable source today. Next, we talk about evolution of wind turbines. So from 87s to 88, first turbines resemble windmills, and from 20s to 70s, industrial turbines start of commercial use, and next years, from 80s to 00s, modern turbines were made automation, and last years from 2020 to 2020s, giant turbines was monitoring systems. Next is a table about examples of use around the world. And wind energy adoption is driven by its environmental benefits, energy security, and technological advancements. It reduces greenhouse gas emission and proves an abundant local energy source, unlike fossil fuels. And globally, countries like Denmark, the USA, China, and the UK lead in wind energy, while Kazakhstan is emerging as a key player with projects like the Zhangatas wind power plant. Next table is a usage examples across Kazakhstan. So Kazakhstan is harnessing its wind potential through advanced technologies and strategic investments. These projects contribute not only to the national energy grid, but also to the global effort to combat climate change by significantly reducing CO2 emissions. Next table about comparative analysis of wind energy technology, and its modern wind energy is more efficient, sustainable, and cost-effective, positioning Kazakhstan as a leader in renewables. Its adoption follows global trends and reduces reliance of fossil fuels. Now we talk about pros and cons of wind energy. Wind energy helps reduce reliance of fossil fuels, but faces challenges like intermittency and land use. Advance in technology and grid integration strengthens its role in sustainable energy future. So here you can see our SWOT analysis. So CO, it's a leverage wind energy's renewable and cost effectiveness to meet global demand and adopt advanced technologies. WO, invest in storage and grid integration while using government incentive to lower costs. CT, it's promote wind energy's low impact and cost benefits to counter competition and geopolitical risks. WT, it's improve grid management and noise reduction to address intermittency and public resistance.
So our strategies. The first way is strengths and opportunities, use wind energy sustainability and the low cost to tap into tech advances and rising renewable demand. Second, it's aspiration and results, aim for global wind adoption and tech leadership, driving lower emissions, job growth, and energy independence. Next, shortly about PST strategies, use policies and the subsidies to lower costs and meeting rising renewable demand, boosting job creation, and social and technological, enhance turbine tech, explore offshore wind, and raise public awareness of wind energy benefits. About economic benefits, first is job creation, jobs in manufacturing, installation, maintenance, and research. Cost savings, cheaper long-term energy independence, less reliance on imports, and stronger energy security. Investments and the GDP boost renewable investments and economic growth. If we're going to talk about economic problems and the barriers, it's high costs, expensive turbines, infrastructure, and the grid upgrades, subsidy risk, dependent on the shifting government support, storage and the backup, added cost from wind intermittency, land and oppositions, costs for land use and the community concerns. Next, it's about potential and actual limitation. First, the potential limitation, it's location limits, needs strong wind, environmental impact, risk to wildlife, and the grid issues, requires upgrades for variable supply. The next one, it's actual limitation with the case studies. For example, in Germany, it's grid bottlenecks and the high prices despite wind growth. In Texas, it's a wind expansion hit by 2021 winter storm outages. In Denmark, it's a high wind use, but relies on neighbors for balancing. So shortly about technological innovations and the future developments, our wind energy is improving only with larger turbines for more power, floating offshore farms for deeper waters, lightweight materials for better efficiency, research for efficiency, storage, and lower impacts, i.e. Optimizes operations, while public and private funding fuels innovation. Next, about implementation strategies. Successful wind adoption needs planning and engagement, its feasibility studies and the community input. Infrastructure and the work phase, it's modern grid, storage and the skilled labor. Risk management, it's a mixed wind, solar and the storage, weather resilient turbines. Optimization, it's about IE and the IoT for real-time monitoring and the maintenance. Smart execution ensures affordable, reliable and sustainable energy. So conclusion of this work, it's wind energy drives the global shift to renewables, delivering economic, environmental and the tech benefits. Despite high cost and the grid challenges, advances in turbine storage and the IE boost its potential. Nations invest in wind to cut emissions, diversify energy and enhance security. With innovation and the policy support, wind will be key to a cleaner, sustainable future. Thank you for your attention. Goodbye.